So let's proceed to the next example. The question says we should calculate the mass of silver that will be deposited when a current of 2.6 amperes is passed through the silver nitrate solution for 70 minutes. So we are given in bracket, we're given the mass, the RAM for silver, and the value for Faraday. 1 Faraday is equal to 96,500 coulombs. So how do we go about solving that question? Now, as we can see displayed on the screen, that our silver, to calculate that, whenever we are given questions like this, to calculate the mass of an element that will be deposited when a given quantity of electricity is passed over some time. So depending on what the metal in question is, looking at the electrolytic series, our electrochemical series, we get to know if the charge on that metal is +2 or +1 or even +3. So if we have zinc, for example, if the question says zinc sulfate, for example, then it means that when electricity passes through the solution of zinc sulfate, aqueous solution of zinc sulfate, of course this will split to zinc ion and sulfate ion, and then the water also is going to split to hydrogen ion and hydroxide ion. So we are interested in the zinc because the question says we should calculate the mass of the metal that will be deposited or liberated when a given quantity of electricity is passed for so and so amount of time. So what it implies is to write the equation for the liberation of that metal is to simply say, in the case of zinc, for example, we have to say zinc 2 plus, since the zinc will have to be deposited as a metal, then it means it has to gain 2 electrons, and then we have zinc deposited. This is actually how the equation will be written. Now in the case of lead, the same thing. If no matter the charge that metal is going to have, that is to say the value of its oxidation number, like in the case of silver, as we have in the question, this is silver plus, so it means it will need 1 electron to be deposited as a silver solid in that electrolytic reaction. So this is actually how to write equations that have to do with electrolysis. So in the question now, to solve that question, the first thing we need to do is to first of all write out the equation that represents the liberation or the deposition of silver at the cathode, because it's going to be deposited there. So having seen the equation thus written, silver ion in the aqueous solution form plus 1 mole of electron to give us silver solid. The mass is what we are asked to calculate, and current is given to us as 2.6 amperes. Time is 70 minutes. So like we said, unless we're asked to leave our time as written, otherwise we will have to convert the minutes to seconds or hours to seconds. So from what we have, to do such calculation, we have to calculate the quantity of electricity that has passed through first of all. So for 2.6 amperes current to pass through in 70 minutes, what is the value of the quantity of electricity that must have passed? To calculate that is to say current times time, and our current is 2.6 amperes times our time. Time is 70 minutes, which we have to convert to seconds. So we have 70 times 60, that gives us 4,200. So when we multiply by 2.6, we have 10920 coulombs, 10,920 coulombs. So it means that for 70 minutes, 10,920 coulombs of electricity has passed through, or charge, if we were to say quantity of electricity, that is to say 10,920 coulomb charge has passed through the electrolyte. So we are now asked to calculate the mass of the silver that will be deposited. So how do we go about calculating that? So to calculate or to know the mass of the silver that is deposited is to proceed to saying that from what we have, 1 mole, that is to say 1 Faraday of electricity deposited 1 mole of silver from the equation. That is the equation. From our equation, the silver ion plus 1 mole of electron gave us 1 mole of silver solid from the equation. So what it simply implies is that 1 mole of electron led to the deposition of 1 mole of silver. And from our bracket, we have been told that 1 mole of silver is equal to 108 grams. That is the relative atomic mass. That's the mass of silver. So it means that 1 Faraday or 1 mole of electron, 1 mole of electron is equivalent to 1 Faraday charge. And 1 Faraday, as we can see in the bracket, in the question, is 96,500 coulombs. That is the value for 1 Faraday. And 1 Faraday is equivalent to 1 mole of electron. So if we have seen that and we are clear about that, it means then that to know the mass of silver that is deposited, from our equation, 1 mole of electron, or we may say 1 mole of Faraday, since 1 mole of electron is equivalent to 1 mole of Faraday, 1 Faraday. So 1 mole of electron, which is also same as saying 1 Faraday, led to the deposition of 1 mole of silver. So what it simply implies is that 96,500 coulombs led to the deposition of 1 mole of silver. And 1 mole of silver by mass is 108 grams. So we can see that. So what it simply implies is 96,500 coulombs of electricity, which is just 1 mole of Faraday, led to the deposition of 108 grams of silver from the equation given to us. So what will 10,900 coulombs give to us? That is a simple question. So that will be X. So this is actually how to calculate that. So going by all the manipulation, at the end of the day, we are going to have 12.2 grams. So to do this and get it cleared, let us take it to the whiteboard just for those that may not be cleared about that. Let us proceed to the whiteboard to know how to go about that once again. So I know some of us will prefer us solving it on the whiteboard for better understanding. So looking at the question, it simply says we should calculate the mass of silver that will be deposited when a current of 2.6 amperes has been passed through silver nitrate solution for 70 minutes. So what we need to do is, when we bring out our given parameters, that is what has been given to us, the first thing given to us there is current, that is time I. Current is given to us 2.6 amperes, and we are told that it passed for 70 minutes. That is time. It passed for 70 minutes. So if a current of 2.6 amperes passed through silver nitrate solution, aqueous. So if 2.6 amperes of current passed through silver nitrate solution for 70 minutes, it means that some quantity of charge has passed through, has gone into the solution. That quantity of electricity, which is charges, has gone into that silver nitrate solution. So what is the exact quantity of electricity that has entered? That is what we are trying to look at. What is the charge that has gone into that silver nitrate solution? To know that, it is to say Q equals IT. That is the quantity of electricity we care to know that has gone into the silver nitrate solution. And Q equals IT is 2.6 times our time. Time is 70 minutes, so we have to convert to seconds. And by the time we do that, we have 2.6 times 4,200. So that gave us 10,920 coulombs of electricity. So it means that 10,920 coulombs of electricity has gone into the silver nitrate solution. This is the electrolysis we're talking about. This is how the setup is. And in there we have the silver nitrate solution. That is the setup. This is how the setup will look like. And we have the silver nitrate solution. So once electricity is passed into this solution, it will split silver nitrate. This is silver nitrate. Okay, let's do it this way. Silver nitrate will split. We have silver ions and nitrate ion. Don't forget, since the silver nitrate is a salt which has been dissolved in water, the water also is going to split, and we have hydrogen ion and hydroxide ion. So this is actually what happens in the solution, because this is now an electrolyte. So as electricity has gone into that, the quantity of electricity that went into this solution is 10,920 coulombs. That is what we're talking about. So the question now is, this is plus and this is minus. That's our cathode and anode. So the question now is, what is the mass of silver that will be deposited? What is the mass of silver that will be deposited at the cathode? Because silver is a cation going to the cathode. So what will be the mass of silver that will be deposited on the cathode? That is what the question actually wants us to calculate or to do. So to go about knowing the mass of silver that will be deposited on the cathode is to first and foremost know the quantity of electricity that has gone into the solution. And the quantity of electricity that has gone into the solution is 10,900 coulombs. That is what we just calculated. Now, to now go ahead to solve for the mass of silver that will be deposited is to know the equation for the silver dissociation, the silver nitrate dissociation. And to do that, that is what we did previously. To do that, we simply have to say silver has one ion, that is one charge, so it is going to be one electron to give us silver solid. So the silver solid is going to be deposited on the cathode, and this is actually what we need. So it means that for silver to be deposited as a solid from the aqueous state, the ionic state, this is the ionic state of silver, and it will be deposited as a solid state of silver, solid, at the cathode. So for this to happen, silver will have to gain electron to cancel the charge that it is having. So this electron goes to take care of this plus charge of silver, so that silver can be deposited as a solid matter on the cathode. So I'm just trying to take the time to explain what we are having here, so that we get to understand it vividly. For I know some of us are not so clear about calculation that have to do with electrolysis. So that is why we are taking our time to explain this, dear students, for you to get it straight. So now we can see, for silver to be deposited at the cathode, this is our cathode, and that is the anode. So for silver to be deposited at the cathode, it has to gain electrons. That is to say, the charge on silver, this charge on silver has to be taken care of for it to be deposited now as a solid matter, because this is the ionic state. In this state, it's still in the ionic state. So for it to be deposited at the cathode as a solid matter, just like you're doing electroplating, then it means that it has to gain electron, and that electron is what we just saw. Now this is one electron being gained, so it means that one electron has led to the deposition of 1 mole of silver. Don't forget, 1 mole of electron is equivalent to 1 Faraday. 1 electron is equivalent to 1 Faraday, and 1 Faraday is having a value of 96,500 coulombs of charge. So let's not forget that. Now, having seen that, what we now have to say is, okay, from the equation, 1 electron or 1 Faraday led to the deposition of 1 mole of silver. That is to say, 1 Faraday has given us 1 mole of silver, and this 1 mole of silver, by value, it is 108 grams by value. Then what we can literally say that since 1 Faraday is 96,500 coulombs, it means that 96,500 coulombs from the equation has given us 108 grams of silver. But from the beginning of the whole process, 2.6 amperes of electricity entered into the electrolyte for 70 minutes, and that is equivalent to 10,920 coulombs of electricity or charge that went into the electrolyte. So if 96,500 coulombs of charge will normally give us 108 grams of silver, then this quantity of electricity that really went into the electrolyte, 10,920 coulombs, what mass of silver will it give us? That is actually how to go about calculating questions that have to do with Faraday's laws, the first law especially. So this is actually how to go about it. So from here we simply have to cross multiply, and our cross multiplying we have to do with 96,500 times x, which is the mass we are trying to find, is equal to 108 times 10,920 coulombs. And by the time we do that, we are going to have x to finally give us 10,920 coulombs, and we're going to multiply that with, this is what we're going to do. So 10,920 times 108, that gives us 11,79360, and so we have 11,79360. So we simply say, dividing both sides by 96,500, or let's make this quite plain and simple. So for those of us who would like us to take it step by step of the way, we are trying to make this very simple, at least for this first example, so that as we proceed we'll get to become matured in these calculations. So I don't want anyone to be lost. So here we have 96,500 x is equal to 11,79360. So if we have to divide both sides by 96,500, this can take care of that. So x will be equal to, let's divide by 96,500. So you can see we have our 12.2 grams. So it means that ordinarily 96,500 coulombs will give us 108 grams of silver, but 10,920 coulombs will give us 12.2 grams of silver. So this is actually how to go about calculating questions that have to do with Faraday's first law of electrolysis. So we shall look at more questions in order to make it clear for us to get that. So this is actually what we have. So let's proceed to our next question and see how to go about that.